When we think about life outside of Earth, a lot of things are a lot rougher than the surface of our planet that is full of plants and oxygen. So we need to understand where is it that life on Earth has evolved to occupy, and where does it stop? So I wanted to stop here because this is a new installation that we made at this point. So this site also was having this really rich biofilm growing on the tunnel wall. So lots of microbes that were coming from the water and colonizing the rock. Here is our own borehole for this geobiology type experiments, where we want to know how life survives and adapts to subsurface conditions, what kind of energy sources there are, how energy is generated, and how perturbations in energy alter microbial life. This is called champagne bottle because it bubbles a bit. This, so is it going to bubble? Oh, there you go. You can see some small micro bubbles coming out. So this is mostly CO2 and nitrogen, which can be the base of sort of the food chain, the microbial food chain of these deep subsurface systems. So knowing what molecules are available for the microbes to eat is very important. The microbes themselves could be something that have been living underground for extended periods of time, so on the order of thousands or tens of thousands of years. In other sites we've looked at, the microbes in the fluids can be the order of hundreds of millions to billions of years old. What we can learn about this research is more about how biologically available energy is generated in the subsurface. And these are all very important questions when asking about the origin and evolution of life. So the only things that are lighting up are things with DNA. So these green dots are all the cells. So we have things like viruses that are really, really small, and then we have the larger cells. So what we can extrapolate from this is how fast organisms are growing. Something like E. coli, which is a very common type of bacteria, can double every 20 minutes. But things that live deep underground in ancient waters, those cells may grow much more slowly and only double every 1,000 or 10,000 years. By just having two ingredients, water and rock, there's fuels and oxidants that life can take advantage of to survive. There may be other factors that keep life from surviving, say high amounts of pressure, high amounts of temperature, or high amounts of salinity. The majority of these simple organisms, bacteria and archaea, they actually are living in these deep underground environments. So there's more bacteria within these subsurface environments like Bedretto than there are in the ocean.